Let's begin by demonstrating route analysis and selection. We are looking at high-resolution satellite imagery of Kandahar, Afghanistan. For the purposes of this demonstration, imagine that we are evaluating candidate routes from a raid location to a casualty collection point. To start, simply place a route start point and route endpoint by clicking. The application then uses a remote server powered by ground guidance to plan 3 routes simultaneously, which are presented as alternatives to be further analyzed by us, the mission planner. Route A is a preference-based route that aims to stick to well-worn paths like roads and trails. These preferences can be tailored to a specific mission profile if needed. Route B is a constant power route, which means that it is the optimal route given a user-specified power level. Power level is synonymous with the term metabolic rate, which is measured in calories burnt per hour and is an indication of how hard someone is working. Route B is optimal in the sense that it is the fastest or least duration route. Route C is a least energy route. It strives to find the path which minimizes the overall energy required by the soldier to traverse the route. Route C is often very similar in shape to Route B, but not always. In this case, the two are very similar in shape. Notice, however, that Route C's caloric requirement is indeed lower than Route B. This is accomplished by navigating the path at a bit slower pace. This can be seen by inspecting the speed output statistic. To demonstrate a case where the constant power route differs from the least energy route, let's fly from Kandahar to Asadabad, a mountainous area in Afghanistan. Like before, we click to place route start and endpoints. Note that Route B takes a circuitous path, while Route C takes a more direct path. Let's analyze Route C a little more closely. Notice that the elevation along Route C varies by almost 300 feet. The color coding along Route C indicates that there is a hill being crossed. Changing the perspective reveals the hilly nature of the terrain. Also, note that Route C is smaller in duration and in energy expenditure than is Route B. These benefits must come at a cost. Looking at the maximum effort required to navigate Route C, the cost becomes clear. Whereas Route B demands a constant 400 kilocalories per hour from the soldier, Route C will require short bursts of about 7 times that amount. To get a sense for the most difficult portions of Route C, we can color code by effort. As intuition might provide, Route C is most difficult along the slopes of the hill.